Važna pitanja, važne teme, važni razgovori na 45. salonu arhitekture koji Muzej primenjene umetnosti organizuje u saradnji sa Asocijacijom srpskih arhitektonskih praksi. Samo ću kratko da poželim dobrodošlicu u ime Muzeja primenjene umetnosti. Večera su sa nama Lara Katscher i Danilo Dangubić i ja ću da im predam reč da pričaju o tim važnim temama. Izvolite, dobrodošli. Welcome.
So yes, I would need to make a short introduction. Lara is a specialist in sustainable design at Werner-a Sobek-a, green design, right? Green technology. Green technology.
Same thing.
So it's even better.
Yeah.
There is a technical aspect of green. And we are very lucky to have her here. We're very lucky to talk about this issue. This is a very interesting issue at the moment in Serbia due to change of legislation that emphasizes green architecture, sustainable architecture, and everything, and it's everything new to us. We know a little bit about it. I guess we know the starting bit of it. But what's very interesting is that you're coming from Germany. This issue has been around for, what, 30 years now, or even more?
Yeah.
And you have some good and some bad experience, and legislation has changed, and the issues have changed, and we talked a little bit about the future of it. So before talking too much about it, I would let Lara present in a sense of opening issues, and then we will embrace discussion and dialogue about sustainable architecture. Go ahead.
Yes. Hello, everyone. Really happy to be here. Bit of a heads up, I've got a little bit of a cough that I haven't got rid of entirely, so if it gets out of control, anyone from the first row will have to jump in, but I think it'll be fine. I've got water. We should get through it. So if you've already said a little bit, I'm from Werner-a Sobek Green Technologies, General Manager at Werner-a Sobek Green Technologies. Werner-a Sobek is an international engineering consultancy based in Stuttgart, Germany. I'm going to talk a bit about sustainable buildings in cities, a few of our projects, what of the projects that we've realized, what's the like bad or good examples, or like the experience that we've made with them. We're still learning as well, like there is new things coming up every day. So I'd like to give you a bit of an introduction into a few of our projects and into the topics that we're faced with in the building industry. Werner-a Sobek, just very quickly about the company itself. It was founded in 1992 with about 350 employees worldwide. There's also an office here in Belgrade. A few of the colleagues from the office are also here in the audience. We do provide the services of structural engineering mostly, facade engineering, design, building physics, MEPs, engineering and sustainability. And I'm from Werner-a Sobek Green Technologies, which is a separate company, part of the Werner-a Sobek Group, which is focusing on the aspects, specifically MEP engineering, building physics, and sustainability. We've got about 55 employees and are also based in Stuttgart as our main locations. We work on all types of structures and materials, so there's no, like, yeah. As I've already said, we operate and work internationally with a strong focus still in Germany and in Europe, though. So why am I here and why are we talking about this? Like, what are the challenges that we're faced with in the construction industry? Here we can see the change in temperature basically over the last 100 years of the entire world's surface. So this is basically the comparison from now on to the temperature that was mean in between 1890 and 1920, so pretty much exactly over the last 100 years. And then on the right-hand side, we can see the Paris emission paths and the climate risks, setting the Paris target to 1.5 to 2%. So why does that impact the building industry? Mostly because the construction industry is a big reason, or one of the reasons why we're in this situation. Obviously not the only one, but it is a big one. If we're looking at these figures, that the built environment and the building activities stand for roughly, obviously very rough figures, but 35% of the energy consumption, 50% of the mass waste generation, and about 50% of the material consumption. If we look just at the mineral building materials like stone, cement, bricks, etc., it would actually be over 80%, so even a lot higher. And looking at the mineral building materials, and about 50% of the greenhouse gas emissions. So that means that there is a huge responsibility on us as engineers, as architects, but obviously also as investors and builders who demand new buildings and who want to build new buildings. At the same time, humanity is growing at an average rate of 2.6 people per second. So this enormous consumption of materials, the waste generation, the energy consumption, and the emissions associated with the building sector are at the same time faced with growing humanity. So we have to build with less materials, or with less, but at the same time we have to build for more people. So this is probably one of the biggest challenges that we're faced in, that we have to build for more, but we have to build at the same time with less. So what are the challenges and the things resulting from this? Not for the future, but actually for today. Technically yesterday, I should have started with this a long time ago. It's once less and smaller new construction, so we need to refurbish and reuse the existing buildings that we've got. Use less new material. We need to build with something, so what should we build with? We need to build with recycled materials, use recycled materials, and then again, we need to build in a way that it is recyclable, the construction, that we can take the buildings apart and use the materials in the new buildings. So all of those challenges that we see here, they're basically all aiming towards a zero emission construction of a building. We also have to design buildings so there are no emissions during building operation, and at the same time enhance biodiversity and take care of the microclimate. So bearing those construction challenges in mind, I'd like to focus on a couple of key factors and show you a couple of project examples, which would be grey emissions, energy, circular economy, and microclimate. Starting with the grey emissions. So here we see the emissions of let's say, a conventional new building made out of concrete. If we look at the, how does that work? No. Should be a red dot there. Never mind. So if we look at this, like at the beginning, in the construction of the building, there's already a huge part of emissions occurring before the building is even put to use, the so-called grey emissions. Then during operation, there's obviously emissions occurring over the time of the use of the building, which is highly dependent, obviously, on the energy concept, on the energy efficiency of the building. And then usually after about 25 years, there would be some renovations taking place, some new materials, especially like some components being renewed, like windows, etc. And then after another operation phase, the building is then demolished after 50 years, which would be a classic building these days, because some of the buildings that are built today are unfortunately not used for hundreds of years anymore, as they have been hundreds of years ago. Some of those buildings are still in use. So what we see, or what we've seen, if we go one back, is that there's a large part of the emissions that's already actually on the construction side of the building and not actually due to the operation. So why is that? So here's an example of the development of energy standards in Germany. So this is for Germany, but there has been a similar trend in different countries, because there's been quite a big push on energy efficiency in the buildings. So the legislation has, over the last decades, focused on the energy efficiency of building. That means that the energy consumption has gone down, with new energy regulations coming in place frequently, and therefore the operational phase has decreased significantly if we look at the overall energy of the overall emissions over the life cycle. So what's happening still at the moment is that there is a transformation of the energy mix towards renewable, non-fossil generation. So what will happen is that the emissions will continue to decrease during the operational phase, meaning that the construction and the grey emissions will dominate even more and become even more relevant to be looked at. So over the last couple of years, actually in Germany, there's been subsidies by the government for new buildings, which have mostly focused on energy efficiency, which we've basically seen here. So similar to basically the legislation, there's also been, when a building has been specifically energy efficient, you would get subsidies from the government, which were actually quite attractive for investors. And actually only just now, as of 1st of April, they've started to not only give the subsidies to buildings that are energy efficient, but there is actually a second aspect that needs to be looked at, which is there's a certain energy efficiency class that needs to be achieved, but there's also life cycle analysis that needs to be done with certain values to be achieved. So the grey emissions are now also being taken into account in order to get those subsidies from the government. The requirements at the moment are still relatively easy to achieve. So basically we're at the beginning where we've started off with the energy efficiency classes like a couple of years ago, but it is a start and it will continue to become more and more strict. So now I'll show you a couple of projects where we looked at the grey emissions in particular. The Q is a refurbishment project of ours in Nuremberg. We were responsible for the structural engineering and the facade engineering. And there we did a emission study where we looked at two scenarios. The first scenario is revitalization with a partial demolition. So there was a few building parts being taken out with still about 18,000 square meters, but it is a huge project. So there were still 117,000 square meters that were refurbished. And then the second scenario that we looked at was the entire demolition and then building a new building. And in order to make it comparable, like in that scenario, we looked at building exactly the same building in exactly the same standard. So with no differences to what's there. So total demolition and new construction is still relatively widespread these days, because in most cases it's actually cheaper. It's less expensive to tear a building down and build a new one. Also, as we all know, with existing buildings, you're usually faced with a lot of difficulties, like it can be height of the ceilings, which might result in daylight availability. It can also be acoustic problems with the ceiling constructions that are in place. So it is tricky to use the existing buildings, which is why sadly the second scenario is still chosen quite often. So the study that we did here is like at the beginning we looked at the emission development since the start of the construction of the building in 1950s. In blue that was basically the previous estimated emissions of the existing buildings. This is only looking at the grey emissions, so not the operational emissions. And then there is those two scenarios, with one the partial demolition and refurbishment, and then the demolition and the new building. And luckily the green path was chosen in this project, so it was decided to basically go the path of the refurbishment. And in like what we've calculated was basically that it was that the sort of demolition in a new building would have resulted in 148% more emissions, which is, well, roughly 2.5 times as much. So here you can see it basically the same thing in a bar chart, which also shows you the proportions of demolition and rebuilding. Demolition, that must be said, is here without transport, so there would be transport emissions that would have to be added onto it. So this is not considered in this case, but it only makes up actually about 10% of the total emissions. Also, what needs to be said in that case, I mean, this is a study that we did that was obviously based on certain parameters that were set. So like, as I've already said, we assumed that the new building scenario would be exactly the same as the old one. There is obviously aspects like, for instance, if there might have been materials from the old building that might have been able to be used in the new one. This is something that we didn't consider in this scenario, but at the same time, as any structural engineer, if there is any in this audience, might know that with old buildings, hard to build actually in the same way, because legislation have become more strict. There's a lot more security factors in the calculations. So at the same time, we might have had to build with thicker ceilings than they were able to build back then. So there is obviously a few factors in there that make this only a rough estimation, but under those parameters, this is the scenario that we calculated. This is an image of that sort of partial demolition. There's like an atrium space that was created with where we took out a few ceiling bays in between the load-bearing structure. So the basically the results of that study was that the savings actually was about 33,000 additional greenhouse gas emissions that were basically avoided, which would correspond to roughly 190 million car kilometers, 1 million trees that bind this carbon dioxide over a year, which would have to be planted on about 3,500 football fields. So these are enormous figures that make quite clear that we need to look at the resources that we've got and how we build and how we treat, especially these sort of massive projects when it comes to the basic decisions of, is it going to be a refurbishment project or is it going to be a new building? A second project where we did basically is the same study or similar study is the quarter in Austria. Here again, we did basically a sustainability study where we investigated whether building a new quarter or converting its existing structures with like very complete program of renovations, etc., would have a greater impact on the greenhouse gas emissions. And also here the study demonstrated then that the converting the original buildings would actually result in 67% less fewer greenhouse gas emissions overall. Don't have such a nice image like we did with the first one here, so it's just an image of the project. And ultimately also here the scenario of refurbishment was selected and is currently in the planning process. So this is a couple of examples of how to approach grey emissions. Quite obviously, using existing structures is not always an option. Because there might not be an existing building there, or in some cases, actually, the existing building might not actually be able to be used. So for new structures, it's important to look at the project-specific requirements and then find the ideal structural system. So if we look at the grey emissions of a conventional new building, again, a concrete building, this is from one project example. Obviously, it's different in every project, but as a rough overview, there's the grey emissions that are mostly almost 60% that make up the concrete and the reinforcement, and then 30% roughly with the facade, and then the rest is among the building equipment and the other components. And then if we look on the figure on the right-hand side, we see that the large proportion is actually the ceilings with almost 40%. So this is one of the main things that we need to look at, and this is how we need to approach new buildings and new construction, and the planning process is finding the ideal structural system for each project, which can be in some cases alternative construction methods, like using wood construction, or also like combination of wood and concrete construction. It can also be hollow body ceilings, which are very optimized in regards to the materials being used. So looking at all of those different scenarios, always taking all of the aspects into account, because one thing is obviously the structural engineering, the properties that need to be right, it's a sustainability aspect, but then also aspects like acoustics need to be taken into account. Can we achieve the acoustic requirements depending on the building usage? So it's always relatively complex and trying to incorporate every single aspect into the decision. So alternative construction methods is obviously one scenario, but then even if none of these alternatives is suitable for the project, it's still sort of looking at the structures in particular, sort of, and making sure that there's no over-dimensioning in the calculations, rather than not just getting out the 25 centimeters of concrete, because that's what we're always building, but actually look at the building, do the calculations properly to sort of find the ideal scenario for each project. And this is the good thing about the latter thing, is that whilst with wood construction, you're very dependent on the client, on the investor. Are they up for it? Is everyone on board? Because with wood construction, there's usually also higher costs associated with it. But with just from an engineer's point of view, with the latter option of just like sort of making sure that there's no over-dimensioning, every structural engineer can influence this. So this is sort of the baseline and the goal for all of our projects, that it's material reduced structural systems. So this is just a couple of, it's not just renovation projects that we do, this is a couple of new projects, but I'm not going to go into more detail about them. But there is like one on the right-hand side is, for instance, with a wooden structure. So that was about the grey emissions. As we've seen in the when we looked at the life cycle of the grey emissions of a building, I've been talking about that the energy, the operational phase is becoming less and less. Even more so still, whilst the grey emissions might be dominant, we still need to look at the energy consumptions and the emissions during the use phase. Firstly, because there's still emissions associated with it. Just because it's less doesn't mean that we can't just neglect it. So there's still emissions associated with it. The path with the going towards non-fossil energy generation is still on its way, and we will still be on that path for a while. And then secondly, obviously also because of the social aspect and the associated costs, because there's always costs that come with running a building, which we need to take into account as well. And the energy bills are a factor in that. So looking at the energy efficiency of buildings is probably the most known part of all of those topics I'm going to talk about, but it's still an aspect that we need to look at. So the approach to that is like with intelligent energy concepts, like, and the most important part of the energy concepts is looking at both active strategies, but mostly also passive strategies. So looking at like solar gains through windows, what are the passive strategies, like without actually using any energy, what can we do to reduce the energy consumption of the buildings, which would be like, for instance, as I've said, solar gains. Like in summer, we don't want them. In winter, we do want them. So looking at adaptable strategies to make use of those. One important tool is always simulations, all sorts, in this case like a photovoltaic simulation. But this is always a tool that can be sometimes quite hard to sell to the client at the beginning of the project, because why do you need simulations? You can just calculate it, but it is the best way to efficiently find the right system for the project. So this is the Futurium, or formerly called House of the Future in Berlin. It's an exhibition and event building in Berlin, and we did the facade engineering, sustainability consultancy, building physics, and the sustainability certification, all sorts of things that come with it, like life cycle analysis. One focus on the consultancy was the close cooperation with the MEP planner in this case, to find a joint optimization of the energy concept. So the result here was an innovative energy concept with regard to active and passive measures. And thanks to the comprehensive consideration of all sustainability issues, the building fulfills like B&B gold standard. B&B is a German certification system similar to like LEED, BREEAM, but it is the certification system that it's used in Germany for public buildings. So actually it's compulsory for all public buildings to be certified according to this system. And the House of the Future, as it's called, is, I guess it was to be expected, but it fulfills the highest standard. That was the goal set from the beginning. Despite its sophisticated, very interesting architecture, it is a primary energy plus building, which was made possible because it's a very compact design. There's a lot of passive measures used, especially in regards to the building envelope, and there's strictly demand-orientated air and energy supply, and very highly efficient building systems, with using a lot of solar thermal energy and photovoltaics, and electricity storage systems. So at the end, with those storage systems, there's actually the demand and the generation peaks that can be balanced out. And in the annual balance, the building provides a primary energy surplus of 8 kilowatt hours per square meter, or 99,000 kilowatt hours per year. Those figures are in relation to the German Energy Efficiency Act. So according to the German Energy Efficiency Act, for instance, what is taken into account into these calculations is things like lighting, all of the building technology. What is not taken into account is things like laptops, sort of the user equipment that's brought in. So there is, those energy consumption is then obviously added on, but it's always quite hard to account for that. Another project that's currently, like the first construction phase is finished, so this is actually an actual image, an actual picture of the project, or of the first part of the project. It's the Plus Energy Quarter. It's a Plus Energy Quarter in Stuttgart, based on Werner-a Sobek's so-called active house modules. It's a total of 6 buildings, and it's the largest wooden house quarter planned to date in Germany by a single investor. So it's not the biggest quarter, but the biggest quarter by one investor, and it's all prefabricated timber modules. It's only the underground car park that's obviously still made out of concrete. And the goal of this project was to make it an entire Plus Energy Quarter. So this was done by PVT collectors that generate electricity but also heat, and which serve as a source for the heat pumps. And then there are small exhaust air heat pumps that are also then put into the main circuit of the heat pumps. The entire building envelope is built according to passive house standard, and in an annual balance, then more energy is actually generated from sustainable sources than is needed. This efficient energy concept was also made possible by means of simulations. So there's a lot of simulations carried out here by the MEP and technical building equipment, because the purely static regulations approach is just not that useful in those cases. So this is also an image of this. So the first part of the project's been completed, and now the second phase is just in construction. Right, so grey emissions and energy, I think those were probably relatively already quite widespread topics that most of you have heard about, and they've been probably they've been in the press for a while. Circular economy is something that is becoming more and more relevant. There's not been such a big focus on it, also not in Germany. There's no sort of strict regulations that buildings have to comply with certain standards in that regard. So this is something, well, probably to start with, obviously, like what kind of economic models are there? There's the linear economy where everything is wasted at the end, and there's recycling economy, which is it's probably the standard these days. We try to recycle a lot. Recycling economy means there's a lot of downcycling though, or like some of the things are recycling and reuse, but there's a lot of downcycling and still some waste being generated. And then there's a circular economy where all materials are kept in the loop. And as you might have guessed, this is the model that we need to aim for in the construction industry, meaning that the materials that we use in our buildings can be taken apart at the end of the building's lifetime and then can be used without being wasted in the new building. Either they can just be used as they are, or maybe there's also some processing done, but this is what we should aim for. And a prime example for that is the experimental unit of mining and recycling, UMA, in the research building Nest in Switzerland. So it's the module in the middle. It's an entire big like research project, and we developed the middle section, the middle unit for it. The principle of the design is that all resources needed to produce a building must be fully reusable, recyclable, or compostable. So that was the design thesis for that project. And so therefore the project can be seen as a temporary material storage. The materials are stored there, or as it serves as a storage unit, and then they can be used in other projects or otherwise afterwards. So the building is completely prefabricated building from a modular construction, as you can see here. And with those images on the right-hand side, you can see how it was then put into the left-hand side is still when it was prefabricated, and the right-hand side is when it's actually put into the building. The principles that play a role here is reprocessing, is reusing, and compostability. For example, those door handles in the middle, they were reused from another project. They were taken out of a building that was about to be torn down and then reused in this unit. In order to ensure deconstructibility and recyclability, obviously the connections are particularly important, because if we glue everything together, we can't take the materials apart anymore. So there's also only like screws and joints and brackets being used, and no actually glued joints in this project. We experimented a lot with alternative materials, which is easy to do in an experimental project. It's sometimes harder to do it in the regular projects. But so I'll show you just a couple of examples. So this is, as you can already see, I guess from the color as well, is a denim insulation product that was made using old jeans. So usually those old jeans would end up in landfill, and in this case it was processed into felt-like matting. And since the textile industry produces massive quantities of waste, especially with the fashion these days, if we look at some of the shops where it's like literally only the shops are, the clothes are sold to be worn once. So reusing this resource is an obvious step in the right direction. And there was an infill insulation made out of hemp fibers, which were stabilized with cornstarch fibers. Obviously, because it's a natural product, it allows to be fully composted after its use. It's got relatively high insulation values and offers quite good fire protection, also good acoustic values. And this was an interesting and new one. It's like the root systems of fungal structures that consist of a very dense organic networks that can be used to make substrate panels or insulating materials. And also because it's a natural product, it's fully compostable. Here, I guess from the image alone, you can see what this product is made of. It's like shredded drink cartons that are made out of composite materials. So it's like the materials that the carton consists of is paper, aluminium, and polyethylene. And by a hot pressing technique, they're then turned into new paneling. And there's actually no added adhesives needing to be used, because there is already still all the ingredients in there that bind them together. So this is an example of downcycling. You can't use that again afterwards. You can only use it for what it is, but still better than putting it into landfill in the first place. And then one last example would be a magna glass, which is made out of waste glass that is initially broken up into shards and then undergoes a complex sintering process that only involves effects of temperature and time, and then make quite nice glass panels. So the project, I guess, proves that the ecological material selection does not necessarily mean that design demands have to be waived. It is actually, on the contrary, it is sometimes quite the intensive examination of cycle-friendly building methods and the questioning of the standards inspires sometimes the architectural quality, because you're made to think like in alternative ways. You're thinking about like what are the different things that we could do, so it can be quite inspiring. With it being a research project, it's unfortunately not a building standard yet. So this is a relatively unique project as it is at the moment. And what can be a first step, though, it is a very small first step, but is sustainability building certifications, because they evaluate a lot of different aspects, and among them is, for instance, one of the criteria that is evaluated in the sustainability certifications is the deconstruction and recycling possibilities. So it does make you think about these aspects, it does make you evaluate them and question them, and even though in the certification system there is no sort of minimum requirement that has to be achieved, so every project can still get certified even though it doesn't comply with any of these issues, but it is a good start to make people and project teams think about them. So we do a lot of sustainability certification projects, all sorts. Most of them is DGNB, which is the German version, similar to LEED would be the US, or UK would be BREEAM. And one of the projects where we did that was, for instance, the Nuremberg Trade Fair Center, where we did the sustainability certification according to DGNB. So we did life cycle assessments, life cycle costing, also recycling concept. And at the point of certification, this was then back then also the highest rating level in platinum in the category of assembly facilities. So this project is certainly, it's completely different. It's not comparable to what we've just seen. But as I've already said, the certifications, the sustainability certifications force those aspects to be evaluated. So it is a very small but an important step to start with and to think about these aspects. So grey emissions, energy and circular economy are all topics that are mostly looking at the building itself. So how can we construct a building looking at these aspects? There is relatively little influence on actually the surroundings when looking at these aspects. The last key factor I'd therefore like to talk about is the microclimate, because it is something that looks beyond the building itself and is quite important if we look at how our cities develop. Because one thing is like being in a building that is sustainable, but you also, well, the majority of our time we're inside buildings, but we do want to enjoy the time that we're outside them as well in the cities that we live in. So the parameters of radiation, wind, temperature and humidity, these are the main aspects that influence the microclimate. And all of them can lead together to the so-called heat island effect that we all know, that it's in the cities a lot warmer than if you're outside the cities. So there's also a schematic representation of a city under better and under worse consideration of the urban microclimate aspects. So the factors that need to be looked at in more detail to improve the microclimate are vegetation, bring green into the cities, it's water, water surfaces, materials, all sorts of materials, whether it's like on the floor, but this is where also the buildings become relevant. It's the facades, it's all the materials that are in the city that contribute to the microclimate, and it's shading and the supply of fresh air. So all of these need to be taken into account when looking at the urban planning level, when planning out quarters, but there is some projects where it's, or like most of the projects are actually only individual buildings. You're planning one building, you're planning a new office building, a new residential building, and in those cases it's actually looking at that side as well, and there is a lot of architectural measures when designing a building that can be taken and can contribute to the improvement of the microclimate. in order to verify and evaluate these measures, taking the planning process, there's extensive microclimate simulations carried out, so to evaluate what is the concepts that we're thinking about, how effective are they, and like look at different scenarios and compare them. So one of the projects that is actually currently in the finishing phase, like the first tenants have moved in, there's only the last few bits that are being done on it, is the Calver Passage in Stuttgart in Germany, where we did the services of facade engineering, including the very dominant green facade in this case, and the sustainability consultancy and the DGNB certification. The building will be certified according to DGNB Gold. At the moment, we are just putting together the final documentation to hand it in to be certified. The building stands out quite obviously due to its green facade, which makes an effective contribution to the microclimate in the surrounding area, and which we can see here. So this is already actual images. Green facades have a lot of advantages and disadvantages, but starting with the advantages, I guess it's probably the most obvious one, it's the improvement of the cityscape. It helps the well-being of the people in the city, it makes you feel good, it's like a quality of life that it brings to a city. Especially in that project, it's one of those where people like walk through the city not knowing where they are, and then suddenly they're just looking at that facade and admiring it. So this is to the outside, to the city, but also from the inside. It's nice to see the green from the inside. Another advantage would be the rainwater management, so the retention of rainwater in the substrate, which then leads to a delayed release, which is in this type of green facade a lot more than it would be in a horizontal vegetation. Then biodiversity, so it provides very valuable habitats for various animal species, especially when you use local plants. But I mean, biodiversity depends on who you ask. It can also be seen as a disadvantage because quite obviously when you open your window, the chance of an insect coming in is a lot higher than if there wouldn't be a green facade right outside the window. So yeah, probably depends on the point of view in that case. Evaporative cooling is quite a significant factor because with the plants, they can actually decrease the temperature by 1.5 to 3.5 Kelvin compared to the temperature around it. There's obviously natural shading aspect, which also leads to a reduced surface temperature. Noise protection can be for both ways. Again, noise protection both for the inside, so it provides noise protection if there's a very busy road outside. It provides noise protection for the people that are working inside the building, but then it also absorbs noise, which makes it on the outside in the city actually a lot more pleasant. And it's the air quality, because they bind fine dust, which is a huge problem, especially in Stuttgart, because Stuttgart is in a valley, so that we've got a huge problem there with fine dust from the streets. And obviously the plants provide oxygen, and it provides a protection of the facade, because the vegetation protects the facade from external influences such as weather conditions like storms and hail. Obviously, it only protects the facade if there is no damage by the roots of the plants. That can be rolled out. Disadvantages, well, first point is like a bit the higher planning and production costs, depends on what kind of way, from which perspective you're looking at it. It is obviously a lot more expensive. You need additional materials, you need additional specialist planners, so it costs you a lot more. And in that regard, in that case also, this is a bit of the tricky scenario. There's a lot of higher grey emissions that are associated with it, because all of those steel structures underneath that are used to hold the plants, they wouldn't serve any purpose if the plants weren't there. So it's that kind of evaluation that needs to be made. What is the green facade worth to me? Its maintenance, quite obviously, they need to be maintained in a very regular cycle. It's a continuous water supply that the plants are needed, because this facade is obviously only nice if it's green. No one would be looking at this building if it would be brown and dry. So there's a big issue with the continuous water supply, and in this regard, obviously, you need to look at very specifically at the like grey water use, etc. Like how can you reduce the fresh water actually needed in this case. Then there's a pest sensitivity. You've got a lot more vegetation close to the facade can bring in pests, and a fire protection, especially if the facade gets dry. This is a big issue that needs to be dealt with. So here's still a few images of the project with like a sort of hand drawing with how it's set up. That was when the plans were put in place. And this is sort of from underneath, so it's like truly fascinating to look at. So anyone who's ever in Stuttgart, it's definitely worth paying that a visit. Another project when looking at microclimate is the Expo Shades. Like, we developed a trio of innovative shading systems for the Expo 2020 in Dubai. All of those shading systems link together all of the national pavilions of the exhibition sites. So the first system that we can see here is multi-layered horizontal cable net structures with approximately 3,500 membrane elements in those bird-shaped membranes that span up to a size of 4 meters. So they actually, like, all sorts of different sizes, but some of them up to 4 meters big. The second shading system is also a membrane structure that can be moved if there's excessive wind loads, and the design offers shade during the day and can be used as a projection surface at night. And then the third system was like a system made of pergolas, which then also had plants put in place with around 11,000 climbing plants that offer shade, but at the same time provide natural cooling via transpiration. All three shading systems were constructed in a way that they can tolerate high deformations. So there's quite large spans being used so that they don't compromise the views on the surrounding landscape. And the third project I'd like to show you in the context of microclimate is another green facade. So the Köbogen in Düsseldorf. It's an office and commercial building where we did also the facade engineering, and it's planted with more than 30,000 trees. And so here we can see them. Obviously, they weren't put up and then waited to grow. They had to grow before, and then they were put into place. So the facade looks like this once the building is actually, because we can see it in this picture. At that point, the building wasn't actually finished yet on the interior. So this, well, we've already talked about the advantages, but also disadvantages. It reduces the solar heat radiation, stores moisture, and this facade roughly absorbs as much carbon dioxide emissions as 80 large trees would. This project was also certified. We didn't do the certification of this project though, but it was also certified with the highest possible certification, platinum level of the German Sustainability Building Council, the DGNB system. Yeah. So these were a couple of projects. So focusing on those factors, grey emissions, energy, circular economy, and microclimate. Why did we talk about those factors? Why did I show you those examples? Going back a bit to the challenges that we talked about and that we looked at. I'm not going to read them out loud again, but truth be told, it's hardly ever possible to incorporate them all into your projects. As you've already seen, I've shown you specific projects for all of those key aspects, because it's purely because obviously I wanted to show you a wide range of projects, different types of project, different approaches, but also because there's no project that serves them all. Like, for instance, the House of the Future that we've seen, the building in Berlin, it's got a very innovative energy concept and strives for zero emission operation. Doesn't have any positive impact on the microclimate though, whereas the project that we've seen lastly that have a great influence on the microclimate do not have an outstanding energy concept, for instance, or a recycling concept. So this is a bit that the problem that we're faced with, that it's not so easy. There is no very clear path. This is all the things that you need to comply with, and then you've got the perfect building. There's like all sorts of different aspects that need to be taken into account and that then need to be evaluated. So, but how do we, what's the process to a sustainable project? How do we start those projects? Or how do we try to start those projects? It's at first we do a context analysis. So we do ask the questions: what is sustainable for the client, what for the location, the use of the building, what are the project-specific requirements, what are the project-specific aspects that come with the location or with the usage or with the client. From that context analysis, we do then put together a catalog of requirements that emerges from this and make a prioritization of the requirements and the definition of the goals. Important in that regard is always that the goals need to be verifiable. It needs to be achievable goals that we can actually look at and define as goals that we can achieve. And after this goal definition, it's in a criteria catalog, so where we put all the strategies, the measures together, and the evaluation of the achievement of the objectives. And most importantly, it's asking then again those questions: what needs to be achieved? How is it feasible? And very important, who's responsible? Like, who's the responsible part in the project? Is it the client? Is it a specific person in the project team? And this is where everyone comes in place, because all of those criteria, they affect a lot of different disciplines. It's whether it's a structural engineer, whether it's a building physicist, or whether it's the MEP planner. So who's responsible needs to be defined quite clearly, otherwise it gets forgotten about. And what we then try to do is, which is obviously also a bit dependent on the client, whether he goes along with it, is then track it constantly with a sustainability manager, someone who's got that catalog inside throughout the entire project. Sometimes it needs adapting because there's new topics that come up, but that's how we then try and track it constantly to make sure that they are actually achieved. So that at the end of the day, we can build for more people, but with less. So this was a lot of input, a lot of different topics, a lot of different projects. If there is any specific questions, feel free to ask. But what I think I liked, but also you would quite like, is if there is, we can be quite open for an open discussion. It is a difficult topic. So I'm very interested in your views, in your opinions, in maybe your experiences from the projects that you've got or that you've worked on or that you've heard about. So feel free to contribute. Yeah.
Well, thank you. There's so many issues, and I'm no specialist of sustainability and the green. So I will start with a question. How do you go with the process of educating a client that they need? What are the factors, what are the parameters that you blow at them, showing how potentially this is good for them in short and in long run? Yeah. Depending. That's something that will be very interesting for us. And also a second part is, I presume that professionals like you will be more and more present at our offices here with the new legislation. And maybe an insight, how did this develop in Germany as well? Because we saw Werner-a Sobek 1992, yeah, and then 2007, right? Or 17?
Well, 2007, Werner-a Sobek Green Technologies was founded.
Right.
Like, there was already sustainability aspects in the planning before that. I mean, Werner-a Sobek himself, he, like, from the beginning on, he was a pioneer this kind of engineering, but that's when they founded specifically a company for those services. But probably start with the how do we educate the client?
Right.
It's a tricky one. It's like, well, probably the standard is when we try and sell our, let's say, additional services in regards to sustainability, because it's not something that is required. It's not required to build according to a circular economy or to reduce the grey emissions, or at least not yet. So first, you're obviously always faced with, well, why do we have to pay for that extra? And then you're kind of in the situation where you start explaining that this is good for the environment, that this is the way to go. But what we then, with most of the measurements, actually, what is the way to sell it to the client or to educate him is like to make him look at the long run and not just look at the investment cost at the beginning, because the investment cost, well, it's planning cost, you need to pay an extra consultant, but also it's the investment when it comes to like the investment of the project itself, which would be higher, but making him look at it in the long run and seeing this will pay off eventually, because you will have a better building that in the long run serves you better. This is always trying to make him see that, which is easier with some, more difficult with others. It depends whether it's an investor who just wants to sell the project immediately after it being finished. So for those kind of clients, it doesn't necessarily matter what happens in 25 years, but especially for investors and clients who hold on to the property, for them it is a relevant issue to look at it in the long run and make them see that. So this is how we're trying to get into their heads.
The difficult business of getting into the head of a client.
What was the second question? Sorry.
Well, the second was, you started actually with the second, with this transformation or embracing of green technology and this shift from traditionally planning and designing office into an office that has additional services, and that those services infuse the design process. So that's because most of people here are professionals, either working or running offices. So this model or the know-how of transforming your own practice and redesigning it so it has a sustainability in its concept of design.
Well, I think so even all of the people that work in our company or that work specifically on sustainability, they all got either an architectural or an engineering background, because with those kind of topics, it is very important to have the technical background behind it, and actually, because there's no point in someone telling you that you should build differently if then the structural engineer is saying, well, that's a nice try, but it's not possible. So it's having that technical background is important, and then just starting to think about what can I do with my knowledge. So I know all the technical aspects, I know how to optimize my calculations or everything, and then using that expertise that everyone's got, which can be all sorts of, it's a structural engineering background, it's the MEP background with the building technology, it's the building physicist's background who knows how much insulation do we need and how can we improve thermal bridges, things like that. So it's all of those technical backgrounds that's very important to then be able to run a good sustainability consultancy, but therefore it's also impossible for everyone who's got a technical background, who's got that expertise in one of those areas, to actually learn a bit more and then become a sustainability consultant himself in his very same area.
Thanks.
So.
My name is Werner-a. What percentage of recycled materials you have been able to use in your projects? What's your experience? Having in mind that there is no plant for recycled materials, is it maybe from time to time more costly?
I can't give you a specific percentage number, but it is very few, to be honest. I mean, what is
It is very
few?
very
Few. I mean, pretty much in all of the projects is obviously recycling concrete these days, but that is actually, when you look at the concrete, the main part of the emissions is due to the cement. So recycling concrete it's a bit better than normal concrete, but it's not a huge step in the right direction, especially as like you also always need to look at the transportation emissions. So recycling concrete is only ever good when it's locally available and not when it has to come from like really far away. So obviously there's a lot in use, but in regards to other materials, it is very few projects where you can actually use recycled materials. There's a lot with facades. We've been able to like obviously aluminium, and there are some materials that they're also like big companies that produce windows. They would promote that they use a lot of recycling aluminiums for the window frames and things like that. So there is some parts, but like for instance, looking at those panels made out of cartons, it's something that's mostly been used in a research project so far. So we're trying to push it, but there is also like obviously regulations that sometimes make it quite hard. So it's once the recycling material being available, that is one problem, but then also being allowed to use it. Because once it has any sort of, well, for architectural, just purely optic reasons, you can use pretty much everything, but then once it has any sort of structural function, it becomes quite hard to be able to allowed to use recycled materials.
Thank you.
Well, who finances your research projects? Is it your company? Is it Germany? Who? Because we don't have that concept here.
Well, I mean, we've only got very few research, but like it's not the majority of our project is not research projects, so the majority is regular projects. But with those research projects that we've did, it's usually funded either like we did a project, for instance, in Berlin as well. It's either funded by the government or by research institutes. So usually there's obviously two factors to it. There is also a lot of investment from the company itself in it, because it takes a lot more time and resources in these projects than it would do if you were in a conventional planning project. But most of them are funded through different organizations or governments. Yeah.
Hello. I would like to ask something connected with Daniela's question about our client. Do you have any calculations you connected with the prices of refurbishment and the new building and the difference between them, and how to communicate this with clients? Because this is our main problem here. Thank you.
There's obviously different regulation when it comes to, so there's no regulations about the grey emissions in that, what we've looked at in those studies. There is different sort of regulations, obviously, when it comes to refurbishment projects and new buildings in regards to the energy efficiency. There is obviously a lot of higher standards when it comes to new building. What has been quite changing in the last few years in Germany is the sort of the subsidies, like the projects that are subsidized by the government, where you get money from the government for higher energy efficiency. And what they've done is that they've now but actually only over the last few years, or over the last year particularly, that there's bigger subsidies that you can get for refurbishment projects than you can get for new projects. So that kind of gives you an incentive it doesn't necessarily make up the gap, doesn't mean that it's then at the end the same costs that you're looking at, but the incentives are there for refurbishment projects, because that's obviously where the government is trying to push you to say, look, we're giving you more if you refurbish your building rather than if you build a new one. But in regards to the grey emission studies, that is mostly just for us and for the client, but there is no regulations behind it that would say once you do these calculations, then this is anything in regard to any regulations.
So I'm coming back to the topic of these gray emissions, because somehow it's the thing bothering me also working, and also lack of kind of knowledge to convince maybe the client, not knowledge, but like lack of argumentation, because there is no really regulation. So I'm wondering your position, like, is the carbon tax the way to go in this sense, that the gray emissions actually can be kind of taken into account and actually priced? Or, and additionally to that, if it is this way to go, or what would be the way to go, are you also politically active as such a big engineering company to actually push these things forward that make the new base of working ecologically and sustainably?
Yeah, so the EU taxonomy and things like that have come into place. They are certainly a big push factor that would make investors and companies and clients look at the grey emissions more and more, because it's become more and more of a topic that actually also with like financing institutes that they only finance your projects if they have a sustainability aspects in them. Like with the carbon emissions, or like with the grey emissions, it's two things. Like with the scenarios that we looked at when looking at refurbishment projects, you can compare it quite easy, like one scenario versus the other one. What we always also do in new projects, when you look at different kind of scenarios, different kind of structural systems like wood versus concrete, or different kind of concrete structures. Sometimes what helps is also saying, I mean, reducing grey emissions with a different construction system itself is one thing, but if the client is already fixed on one system and is saying like, this is the way I want to build my project, and if you then kind of wanting him to reduce grey emissions, then that usually also means that you're reducing material itself. So there is then actually a cost incentive for the client, because you're reducing the amount of material being used, and therefore reducing the grey emissions. So sometimes that can then be used, but to the political side, yeah, we're trying to influence that. So like also there's a couple of like sort of architectural competitions that are like done by cities for new quarters and things, where we would sit in the jury and try and influence certain aspects, but it is a long process. Yeah.
And I would like also to ask something connected with the microclimate. I have some project I'm trying to push for the city, and my client, the city, told me that they have the informations about long using of green roofs, that it's not sustainable really, and that it's a problem now after 20 years or 10 years after, because of something. So what is your experience with the green roofs generally, and what type of green roof you really suggest, or do you have something other to tell us about roofs?
Well, yeah, this like almost with everything, advantages and disadvantages, especially like if you look at green roofs, they normally need a higher structure, which then might require different kind of structural aspects, because every structural engineer wants to know at the beginning what kind of roof structure do we have. So there is those things associated with it indirectly that you don't
for refurbishment.
For refurbishment, right? Yeah, well, in that case, you keep the building as it is. Well, if you use green roof, certainly got a good positive impact when it comes to using photovoltaics, because they cool the modules from underneath. So in that case, it is certainly recommended to go ahead with green roofs. Generally, it is something that we would want to see in our projects, even though there are some downsides with it. But overall, probably to sum it up, we would use green roofs mostly in our projects if we can, if there is no obvious downsides with it, like for instance having to put more foundation in or anything in order to hold it. But especially with refurbishment projects, I wouldn't see any reason why there'd be a downside to it, really.
Thank you. I'll use it.
Thank you for a very informative presentation and lecture. I'd say that until now you got like that Serbia is a tiny bit far from this what is happening in Germany or like in western part of Europe, but like it's starting slowly to be a hot topic with all this now implementation. I think it might be there is a slight risk of sliding towards a greenwashing, maybe, or like, could you tell us more about like how to avoid this tendency, like promoting one or two elements in a building that are green, but actually majority of the building, or like there is not like a holistic approach or like sustainable, we exclude factors like transport to the building, or like so many different factors and concentrate on one. So
Yeah.
like if you have any experience from German.
Well, it's not a problem just in Serbia, the greenwashing. I guess it's like pretty much everywhere, because sustainability is a hot topic no matter who you ask, and once there's one sustainable aspect about one building, that's what everyone focuses on and tries to sell that as the sustainable aspect. So I guess it's very hard to which makes it quite difficult to actually find out which are the truly sustainable projects and which are the ones that have one aspect, but the other aspects are actually not so sustainable. So it's quite tricky, because on the one hand, it's definitely don't support the greenwashing, but starting with one thing is still better than not doing anything at all. So good job in starting on one of the aspects, even though you then might try and blow it up a bit too much than what it actually is. Something good maybe to start with, but even there is a lot of greenwashing in place, is the certification systems, because they make you look at all sorts of different aspects, especially like, for instance, with the German system, the DGNB certification system. Like if you want to achieve the platinum level, like there is, I don't know, you're probably familiar with the sustainability certifications overall a little bit. There is different aspects that need to be evaluated. And if you want to achieve the highest rating, which would be platinum in that case, there is obviously a certain amount of points that you need to reach, but there is also a minimum amount of points in every single of the aspects that you need to reach. So it makes sure that you're not just focusing on one thing alone, but that there is actually points that you get in all sorts of different criteria and aspects. So it is whilst you certainly can't say that every certified project is sustainable, but it is a good start, because it makes you have to evaluate all of those different factors. And even if some of them you're then not achieving very high points, you've still evaluated them, and you can still look at them, what is actually behind it, and what is actually, how can that project be evaluated in this criteria. So that's probably one way of going at it, but obviously with they're developing the certification systems, but especially like in Germany at the moment is like with those certifications, when they started, it was a huge deal to be certified. At the moment, it doesn't really matter if you reach a lower certification. It's only really a big deal if you reach the highest certification level. So you can also see the trend there, that it's becoming more and more important, and that people are looking behind the scenes and are saying, just because you've got a medal there, it needs to be a platinum medal, otherwise it's not really worth anything to us. So it's one way of starting. Yeah.
Okay. Build for more with less. That's a new mantra. Thank you all, and we'll see you in 2 days.